All right, today we're going to talk about word problems. We're going to go through some strategies that you can use to work on word problems. I've often mentioned, I've taught for a long time, and I've often mentioned when we come to word problems, what is the point of mathematics? If all you ever learn to do is manipulate numbers. You all know when you have an equation, 3x plus 1 equals 12, you all know you subtract 1 from this. What is the good of that if we don't ever use it to do something to make lives better? And that's basically what mathematics does. Mathematics is the queen of the sciences, used in biology, chemistry, physics. Mathematics is used everywhere. And it makes our lives better because it helps us to solve problems, okay? So we're just going to be fooling around with word problems. I'm going to go through the strategies today. I am not going to solve the equations. Once you get the equations set up, they're easy to solve, okay? It's setting them up is the fun or interesting part, okay? So when you do your homework today for these section 1.6 word problems, you will be solving the equations, all right? Let's be clear on that. Make sure you solve the equations. It's setting them up is the really interesting part. All right, so how about some strategies first? Can I do it mentally? Did you ever have a teacher in a math class that insisted you do the problem in a certain way and you couldn't do it mentally? That always used to bug me, okay? I see absolutely nothing wrong with looking at a problem and saying, I should be able to figure that out in my head, right? Can you do it mentally? Let the variable be the thing you know the least about, probably the most important thing I'll say today. And if you forget everything else I say in the next 20 minutes, remember that. You always let the variable be the thing you know the least about. Draw pictures or make tables, that kind of thing to help organize your data. And we'll do quite a few problems in which there are pictures or tables that we will make. All right, number one, Sarah's monthly gym cost includes membership, $47, $12.50 for each Zumba class. If her September's cost was $134.50, how many classes did she take? The Zumba classes. This is a classic problem for doing in your head, okay? You say, well, I know she has to pay the monthly membership of $47, so I could take the $134.50 and subtract $47. Then what is left is everything I had to pay for the classes. So I've got $87.50 left divided by $12.50, and I find out she took 7 classes. Okay, a perfect problem for doing mentally. Okay, now, if you want to do it using mathematics and algebra and variables and all that kind of stuff, how many classes did she take? That's what we don't know. We don't know anything at all about that. I'm going to let that be X. I know I have to take $12.50 times each class. $12.50 times X plus the $47 has to work out to be the $134.50. All right, so if you want an equation to do number one, there it is. All right, and you should get the same answer of 7. Okay? All right, now, number 2. So this was number 1. Number 2. John invested some money at 4% and an amount twice as big at 6%. Total annual interest, what he earned was $14.40. How much did he invest at each rate? Okay, we're going to have to use a variable on this. So, what do you know the least about? The amount at 4% or the amount at 6? Well, the amount at 6, I know something about it. It was twice as big as the amount at 4. The one I don't know anything about is the amount of money I invested at 4. So I'm going to let X be the amount at 4%. Twice would be the amount at 6%. Okay? Now, you earn interest like Grandma gives you $200 for Christmas. Okay? Mom and Dad are spoiled sports. They say you have to put it in the bank. You put the $200 in bank at 3% interest. Next year at this time, at Christmas, 200 times 0.03, you're going to have $6 in interest. You're going to have $206 instead of your 200. You multiply your rate of interest times the amount, that you put in at 4. The rate of interest, 6 times the amount. So the rate of interest, 0.04, I'm going to multiply by the amount I put in at 4%. And the 0.06, I will multiply times the amount I put in at 6%. That total interest is 14. Here is a classic where you let the variable be the thing you don't know anything at all about, okay? And that's, you see what I mean about being easy to solve? These equations are truly easy to solve. Let's talk about number 3. This is a good one. And right away, it's a geometry problem. We're talking about a rectangle. A garden is 6 foot longer than it is wide. We ought to draw a picture. 6 foot longer than it is wide. Find the dimensions of the garden. What's the length and the width? What do we know the least about? We have a length and we have a width. Okay, the length I know is 6 longer than the wide, so I know something about the length. It's the width I don't know anything about. I'm going to let that be W, and the length is 6 longer, W plus 6. Okay? Now, I'm going to put a 2-foot sidewalk the whole way around the garden. This is 2 foot here. This is 2 foot here. These are 2s everywhere, the width of that sidewalk. So if you want to get the bigger dimensions now, the bigger, it's no longer W, it's just here. You put a 2 here and a 2 down there. So isn't this W plus 4? And down here, it's no longer W plus 6. We put a 2 here and a 2 there. Isn't that W plus 10? Right? Okay, so now I've got it all set up. Okay? If the area of the sidewalk is 108 square feet, so I know the area of this little guy, the area of the little guy is length times width. W times W plus 6 is the area of the little guy. If I add on the area of the sidewalk, which is 108, I should get the area of the big guy, which is W plus 4, length times width times W plus 10. Okay? And this one's a little trickier to work out. You'd multiply here, you'd multiply there, and solve for W. Okay? By the way, there is another way you could have done this problem 3. And I just want to take a second and talk to you about it. Another way you could have done problem 3 is to cut the sidewalk up into pieces. Okay? This piece right here that goes from here to here, length times width, is 2 times W plus 6. And don't I have another one down there? So I have 2 of those. This piece right here is W by 2. See it? Right in there? That's 2W, and I have 2 of those. And then I have 4 of these corners. And what's the area of each corner? 2 by 2. 2 times 2 is 4, and I have 4 of them. 16. That's the whole sidewalk, and we know that sidewalk is 108. So that's another kind of a cool way to do it, to take the sidewalk that you know the area is 108 and break it up into all the pieces, and then just add them up to get 108. Okay. Number 4, I am 6 feet tall. By placing a mirror on the ground, I can sight the top of a neighboring building. So what this is going on here, here I am, here is the top of a tall building. I place a mirror on the ground, so my eyesight can see the top of the building in the mirror. Okay? I am 4.5 feet away from the mirror. The building is 40.5. Can you all see that at home? 4.5 and 40.5. Okay? Find the height of the building. This should bring back very, very, very fond memories of geometry. You have a right angle in this triangle, you have a right angle in this triangle. And you have something from science here. You remember how in angles, when an angle bounces off of something reflective, you have the angle of incidence equals the angle of reflection. I think that's what it is. I'm not a science geek, but these two angles are the same. So you have similar triangles here, and you can set up a proportion because you have similar triangles. I am 6 feet tall. How tall is the building? Beats me. I'm going to compare the little triangle to the big triangle. This side on the little one, 6, corresponds to that side on the big one, X. This side on the little one, 4.5, corresponds to this one on the big one, 40.5. Ah, geometry, 10th grade geometry coming back to you. You can cross multiply and solve that. Okay? Okay. Chemical problems. All right, I love chemical problems. You can have so much fun doing these problems. Now, I have 800 cc's of a solution. It's 40% salt. Now let's just stop. No, let's not even worry about the rest of the problem. Let's just talk about that a little bit. If you have a solution that's 40% salt, say it's salty water. If you take 0.40 times 800, you get 320. So there'd be 320 cubic centimeters of salt, and subtract 320 off is 480. Off 320 off of that is 480. There'd be 480 cubic centimeters of water. By multiplying, that'll tell you how much salt you have. Okay? Here's a 70% solution. It's saltier. You would take 0.70 times the amount. You want to increase the saltiness to 62%. Would you all agree with me? When you take a 40% solution and mix it with a 70% solution, you're going to be somewhere in the middle because it gets saltier. If you mix very little of this in, it's going to stay close to 40%. If you mix a whole lot of this stuff in with it, it's going to get pretty close to 70%. Okay? We want it to get to be 62%, so how much do we add of the 70% solution? All right, so here we go. Let's start. We are going to take an 800 solution. I'm going to add a 70% solution. How much? I don't know. So I'm going to add X, and that will give me a mixture of 800 plus X. I think that's the best way to start. All right, I'm taking 800 cc's, I'm adding an unknown amount, and I get a mixture. Now, what's the percentage salt in this first one? Multiply by 0.40. What's the percentage salt in the second one? Multiply by 0.7. Okay? This gives you the amount of salt here. This gives you the amount of salt here. When you add the two together, you're going to get the amount of salt in the total, which we want to be 0.62. Okay? That is the best way to set those things up. Start with what you have, what you're going to add, get a mixture. Then put the percentages in front. Okay. How about number 6? Let's actually go down and do number 7 first, because it's a rate, time, and distance problem. And maybe this will bring back more fond memories of 8th grade algebra class. All right, number 7. Okay. When you're doing a rate, time, and distance problem, make a table. Rate times time equals distance. I have Joe and Dad. Okay? Everybody be able to see that? So rate times time equals distance. I have Joe and his dad. How about their speeds? Joe runs away from home at 50 miles an hour. Dad tries to catch up to him. He's going 65. Now, assuming Dad's on the same road, he will catch up to him because he's going faster, right? All right. Joe left at 9 o'clock in the morning. That does not mean he was on the road for 9 hours. It doesn't say that at all. He left at 9 o'clock in the morning. When does Dad catch up? I don't know. I don't know how long Joe's on the road. X. Okay? Dad left at 10 o'clock. Joe left at 9. Does Dad have more time on the road or less time on the road? And 10 o'clock is bigger than 9. 10 is bigger than 9, but that does not mean that Dad had more time on the road. Dad actually had an hour less because he left an hour later. Now, here's the problem. Some people want to put x minus 60 because he had an hour less, 60 minutes, right? Why not? No. These are miles per hour. Since you're in hours here, he gets an hour less, which is x minus 1, okay? Rate times time, multiply straight across. 50x, take the 65 into both parts, 65x minus 65, okay? When Dad catches him, here goes Joe. He's speeding across real quickly. Dad starts a little late, but he's gone faster. When Dad catches up to Joe, they will have traveled the same distance. Their distances are equal. That's why Dad catches him. He goes the same distance as Joe did. So if the distances are equal, you said 50x equal to 65x minus 65, and you solve. Okay? Now, we're going to use the same strategy to do problem 6 that we did in problem 7. So for number 6, we are going to make a table because your rate of work times the time you put in gives you the work you do. Like, for instance, Sally can mow the grass for 80 minutes, okay? She can mow the grass for 80 minutes. In 80 minutes, John can do it in 60 minutes. Isn't John a little bit faster, right? Sally can do it in 80 minutes. I need to come up with her, let's put here Sally and John. Okay. I need to get Sally's rate, her rate of speed. Now, because it's in minutes, let's keep it in minutes. What does she do? Rate of speed, like 50 miles per hour. What does she do in a minute? Well, not very much. It takes her 80 minutes to do the whole thing. So in 1 minute, wouldn't she do 1/80th? Think about that a second. Her rate is 1/80th. Joe's rate does 1/60th of the job per minute. Okay? How long would it take them if they worked together? The time. We don't know. Okay? Rate times time equals work. T times 1/80 is T over 80 and T over 60. The work that Sally does, T over 80, plus the work that Joe does, T over 60, should be 1 whole yard finished. That's how much work they do together, 1 yard. Get a common denominator for 80 and 60, 240, I think, yeah. You could multiply through everything by 240 and solve. Now, there's another part to this problem. How long would it take if John had a 10-minute head start? So let's fix this up. If he has a 10-minute head start, doesn't he have 10 minutes in when they start working? So he would work T plus 10, T plus 10 here, T plus 10. You do the same thing, multiply both sides by 240 and solve for the time. Okay? Like I said, I am just setting these problems up. Okay? You will set them up on your homework and work them out. All right. Kim has taken 4 tests. What does she need on the 5th test to average 80% for 5 tests? How do you find an average of 5 tests? Don't you add up all 5 and divide by 5? Well, let's do that. Let's add up all 5, 68, 75, 73, 90, and x on the 5th test. Divide by 5, and we want to get an 80. okay? When you have a fraction equal to a fraction, what's the easy way to do it? Cross multiply. 400 equals that, and that's extremely easy to solve. Okay, so on your homework, I've done the same thing. I've looked through all the problems in the book and tried to find ones that are not crazy difficult, but that will give you an idea as to what's going on with these word problems. So set them up and solve them. You'll notice that most all of them are odds so that you can check your answers.